Hi, I'm Brandon Bloom. I lead AI products and AI product engineering at Brex. Today, I'm going to tell you about our audit agent. We make products that include our corporate card for businesses, as you heard Tom tell you about earlier, and we have policy to enforce on those on corporate spend. And so our audit agent finds waste, fraud, abuse, and other out-of-policy spend inside all these transactions in your business. We're going to tell you why we gave this audit agent a bash shell and what happens when we did. So many of you are building powerful agents that are taking on challenging tasks. And allow me to set out the challenge that lays ahead of our audit agent. The industry benchmark is that about 5% of all corporate spend is out of policy. The difficult question posed to us and to our agent is which 5%? To solve that problem, we needed to really understand the natural language policies that drive what it's okay to spend corporate money on. Expense policies are actually really strange. You might think you can have very simple rules about how much money you're allowed to spend, but it turns out everything I'm about to show you is a real policy from a real company. For example, you can only use $75 a day for food when traveling. Unless, of course, you're an executive, you can spend as much as you like. You're not allowed to book an Airbnb unless you've got dietary restrictions and you need to cook a special meal. You can't upgrade for a flight unless you're taller than 6'5" and you really need the leg room. You also can't buy dinner for your friends unless you didn't stay in a hotel and you're saving the company money and you want to thank them for being a good host. These have all been in real expense policies, and there's no rule engine on the planet that is going to be able to enforce in or out of policy for these and the many subtle and interacting rules that a company may define. So once we understand the policy, we need to flag those expenses that might be out of policy, cluster them together, and provide suggestions through our case management system so that you can take action, either remind someone of the policy, request reimbursement, and the like. So here's some real cases in our agent system that show some of this being found here, right? So Sarah took a flight on Delta Airlines. She decided she wanted to extend her business trip to go over to Italy and spent a little extra too much money doing so, and that's not acceptable. Or here, Elena decided to treat her family to a meal during a business outing, and the kids' ramen on the receipt gave her away, right? And so you have to go and read all the line items and complicated receipts, and you have to dig in and understand, like, what is the purpose? Who are these meals for? There's a lot of reasoning the agent needs to do. Or in this case, John really enjoyed the luxury of Uber Black, but he kept upgrading. And over time, somebody said, we've had a pattern of abuse, not just an individual transaction, but many, and are able to recommend, like, hey, please, use a UberX or a lower price card share. So this is all sorts of creative out of policy, creative abuse of the corporate spend policy. And so to catch this creative abuse, we needed a creative agent, which means we had to give it the tools and the skills to go connect the dots and understand what's going on. So we gather up all of our tools, and we take a first naive attempt at writing a tool calling agent. And you wind up with a trace that looks sort of like this. Each of these columns represents a turn of the agent. The pink output there is all the tool response, loads of JSON information, trip output, policy information. And each one of these is cumulative. So by the time you get to the end of this graph, you've bloated your context window mostly with tool responses, most of the information you don't actually need. So when you're talking with an agent's very verbose in this mode, and when you're talking with somebody who's very verbose and they're slow to get the job done, we as programmers have long known what to tell those folks. We basically say, go away, or I'll replace you with a very small shell script. And that's exactly what we can do with our agents. The truth is that shell scripts are a shockingly effective way to reduce the verbosity and complexity of getting a task done. And as all of us work with coding agents, We know that if we write little programs, we can save ourselves a lot of work and intermediary steps that can reduce all that complexity that takes place in that very many turns with chatty tool responses. Every agent is becoming a coding agent, right? All of these models are tuned for coding. That's the first and best use case, and everything else is just gravy. So we want to work with that, cut with the grain, not against it. And so we can turn all of our agents into coding agents and give them the same creativity they use when you build your apps. So Just Bash is an open source library provided by Vercel that is perfect for this use case. It's a totally sandboxed WASM execution environment that provides Bash, custom standard tools like grep and cat, and is programmable from TypeScript. Because it's fully sandboxed in this way, sailed right through security review. Didn't need a complex operational setup with containers or Docker deployments, basically just an NPM library. And when we gave Bash to our agent, the results were immediately dramatic. For example, consider we're auditing the spend of a typical mid-sized company that spends $2.5 million every month, right? That's over 9,000 expenses we need to audit individually and in clusters. And at that 5% out of policy rate, you'd expect around 475 cases to be captured. This represents $300,000 on average of exposure risk to a company out of policy spend in potential. With a traditional tool calling agent, this would take 200,000 direct tool calls and consumed over 6 billion LLM tokens to conduct this audit. That's not an economically viable product for us at Brex at that scale. You're spending more money to audit it than you would have saved. So we needed a way to bring these numbers way down, and our very first attempt, just handing Bash to our agents, produced dramatic reduction. 60,000 Bash invocations instead of 200,000 tool calls, a 75% reduction in tool calls, and a commensurate reduction in token usage. This is wild, and there's so much more room to bring these numbers down, and we have done so since. So look at that first graph that I showed you earlier on top and the graph below. When you use Bash, Bash gives the agent control over all that tool output, so it can bring down all those verbose responses and have a much less chatty interaction to do the same job. In this case, the cumulative number of tokens used, far reduced. It also makes the agent faster. But the critical thing is Bash lets agents manage their own context instead of drowning in it. As a bonus, the tool design work that you need to do when you're building lots of different tools, for example, in a simple MCP setup, you have to do X times Y work. You've got, along the X-axis here, various domain objects we need to interact with. And along the Y-axis, we have various tasks we want to complete: fetching, filtering, grouping, sorting. And we really don't want to do X times Y work. We actually want to do X plus Y work. And this also means that there's far fewer tools. You don't have the product of all these things in your tool context. And this is what the Unix philosophy gives us. The Unix philosophy says to write programs that do one thing well, work together, and handle text streams. It's the universal interface, after all. And this was a great idea in the 70s, and it's still a great idea today. And text streams are an even more universal interface today than they ever were in the past, thanks to the modern agents and LLMs. And so by working with this sort of same tools and leaning into this same philosophy, we can do less work, have less verbose interactions, and get better results. So here's some examples. We have a simple tool, get expenses, that just dumps JSON of all the expenses that are relevant to a particular investigation. You can see we pipe into JQ, which is built into the Just Bash package, standard off-the-shelf JSON querying tool. There's many, many, many fields, several hundred at this point, of information associated with expenses, But I only really care about the ID, the merchant, the amount, the type in this context. So none of that JSON winds up in my tool response, and therefore none of that JSON counts as input tokens to subsequent turns. Additionally, I can save the work of having to make a tool call multiple times. If I'm going to get the most recent expense or the most expensive meal, I can combine these tools through the file system. I pipe the JSON response to the file system, which of course, none of that becomes input tokens. And then I can run operations on that temporary working memory twice using the expenses JSON file, bypassing the context. Additionally, my system prompt gets smaller. These expense policies are complicated, they're big, they often come in PDF format, and they can be tens or sometimes as much as 100 pages of full detail of every little aspect of a business. And loading that into the context window every time is prohibitive. So instead, we can seed the file system with those policies and many other documents. And the agent can use standard tools like grep to find out the first-class flight policy for an organization. This is a simple example, but just this basic level here is what got us those improvements before. And there's a lot of things you can do to index the information, add additional tools to explore it, provide advice on how to get just the context you need, not all of it all at once. So let's see how you define tools that you can add to extend, like our get expenses tool there. It's a very simple process. You import just bash, it's called define command. And then you get args and a context object. The args are standard command line objects, just like you'd have on any command line tool. You return standard out, standard error, exit code. And then you invoke the bash environment and give it a set of tools. And you get all the standard ones in there for free. You can customize as well with the parameters. The same tool design that you would use to make great Unix tools apply here. They make great agent tools. There's 50 years of tradition that you can call upon to make a great developer experience that also leads to a great agent experience. And the system prompt design couldn't be more straightforward. You say, use the bash tool for all audit investigations. Call get expenses to analyze transactions. You can give it some information about some, but not necessarily all of the options your tools have. You know, here we have user and trip to do some pre-filtering, but you can pass -- help if you need more information. Online, inline help is great for developers, and this enables your agents, for the same reason, to explore and uncover and find the way to operate these tools just in time. So here's an example. We'll call get trips. We notice that it passes -- city because it wants to know which trips went to that city, and whoops, that flag's not provided. No big deal. The agent encounters that standard error output, says, I can deal with that. I can solve this problem on my own. I'll use JQ to do some filtering. Might be a little slower, might send a little bit more data across the network, but it's not going to go into my context window, and I can get the job done. And then we proceed to look at policy and expenses and so forth. This is a hallucinated request. This is a hallucinated command line flag. Failures and hallucinations are feature requests. It's your agent telling you how it wants to use your tools. You don't get this experience as often when you work with something like MCP because the agent isn't building on all of that ingrained knowledge of how to use a shell, how to write code. And so you can look at this failure that was inline in the interaction in which the agent ultimately succeeded, your customer still had a good experience, but that recovery taught you something about how to make the agent more efficient, faster, and more successful in the future. It's just like mentoring a new software engineer. You sit over their shoulder and you go, hey, did you know you could pass that flag? It's the exact same skill set applied to agents. So now we go and we teach the get trips command, -- city, and we do it with even fewer requests to solve the next query, get the same job done. So I think the thing to understand here is that just as you're putting together all the components to build your system, you can essentially give a subset of those components as a block to your agent, and the agent will tell you what you need to do to set free the right design. It may be a hallucinated fact. I think it was Michelangelo, but there was a famous sculptor whose name eludes me, who said that like the sculpture was in the marble. And I think your agent's in the marble as well. You take that big block of stuff that is all your tools and whatever agent, you give it a task, you watch it explore, you watch it figure out how to solve the problem. It's your job as an agent designer to set that agent free from all the raw materials you already have. Luckily, software and LLMs are a little bit more malleable than stone. So if you make a mistake, you can correct. And I think the thought that I'd like to leave you with is that if your agent needs to solve challenging problems and exhibit creativity, just like our audit agent finding creative out-of-policy expenses has to do, then just maybe your agent should also be a bash agent. Thank you.